Myself Mehul Kudia from LJ Institutes of Engineering and Technology. So in today's session we have to discuss new chapter, that is engineering optimization. We already discussed 5 chapter of computer aided design subjects. First one introduction, second one that is curves and surfaces, third one that is geometric transformation, fourth one that is mathematical representation of curves, and also we discuss finite element analysis. So in today's session we start new chapter, that is engineering optimization. So in today's session we have to discuss the what is the optimization technique. Okay, so there is a various optimization technique. First of all, you have to understand what is optimization. Optimization means what? Optimization means we have to find out the better solution from the given constraint. Okay, so this is the engineering optimization. So in engineering optimization, first we have to discuss what is optimization in mechanical engineering. Okay, so optimization in mechanical engineering, that means optimization is a method of obtaining best result under the given circumstances. Okay, so it play a vital role in machine design because the mechanical component are to be designed in optimal manner. Okay, so this is the optimization in mechanical engineering. Now what is the optimization in industrial engineering? So optimization occurs in various fields, in mechanical engineering, in industrial engineering, in design engineering. Okay, so engineering optimization is developed of mathematical model of engineering decision and mathematically determined desired maximum or minimum value of objective function. Okay, so in optimization we have to, first of all, we have to define the function, that is for the maximum value as well as for the minimum value. Okay, industrial engineer have to be convert their engineering change idea into a mathematical model and find the best solution or optimal solution. In optimization, first of all, we have to define the equation or we have to define the function. After that, we have to convert our ideas into mathematical form. After that, we have to find out the optimal solution. Okay, so we discussed in this slide, that is a optimization in mechanical engineering as well as optimization in industrial engineering. So next question comes in our mind, why optimization is necessary? Okay, so optimization is necessary because we have to create one model, or we have to create one product with low cost and high accuracy and high quality. Okay, so first parameter, because of optimization we can reduce the cost of product. Clear? So we can reduce the cost of product using optimization. Second thing, from the optimization we can save the time duration for the manufacturing any of the product. Next thing come in our mind, safety and reduce the error. Using optimization we consider all the parameter, and from this parameter we can increase the safety, and also we can reduce the error during the procedure of the optimization. Next thing, reproducibility. Clear? Reproducibility also is the one parameter of optimization techniques. Okay, and also from the optimization we can innovation, means we also do some innovation and efficiency, we can increase the efficiency of the product. So optimization is necessary because of all the other 5 parameters. Clear? So this is the clear answer why optimization is necessary. Okay, next thing, classification of design parameter. Classification of design parameter is most important parameter of optimization. In a design of any mechanical event, a number of design parameters are used. These design parameters, which are related to each other by the number of design equation, can be broadly classified into 3 groups. Clear? Classification of design parameter broadly measure these 3 groups like functional requirement parameter, material parameter, and geometric parameter. Okay, now we have to discuss each parameter in detail. So what is functional requirement parameter? The functional requirement are conditions which must be satisfied by mechanical element if the machine where it is used to functional satisfactorily or not. Means machine is working properly or not, with 100% efficiency or not. Clear? So this is functional requirement parameter. Second one, material parameter. Material parameter are those parameters which describe the material value. Clear? So material is the main important parameter in optimization. For example, what is the density of material, what is the modulus of elasticity of the material, what is the Poisson ratio, what is the ultimate strength. Clear? So material parameter define the value of all these parameters like density, Poisson ratio, or modulus of elasticity. Clear? And third one, that is geometric parameter. The geometric parameter are those parameters which define the geometry of the mechanical element. For example, the geometric parameter for a spur gear are, so in spur gear, how much geometrical parameter come in picture? First one, that is module. Second one, that is number of teeth. Next one, that is face width. Next one, pressure angle, addendum, addendum circle. All are the geometrical parameter of the spur gear. This is one example. Clear? So we have to consider three parameters like functional requirement parameter, material parameter, and geometric parameter. Okay. Now next one. So design of mechanical element. Now we have to design of mechanical element. Basically, mechanical design divided into two major parts. Clear? So design of mechanical element is the activity of selection of material and the value for independent geometrical parameter. Design of mechanical element is classified into adequate design and second one, that is optimum design. Clear? So basically design divided into two major parts. First one, we have to discuss that what is adequate design and what is optimum design. So first we discuss adequate design. So what is adequate design? So adequate design is the selection of material and the value for the independent geometrical parameter for a mechanical element. First of all, we have to define independent geometric parameter. Okay. After that, so that the elements satisfy its functional requirement and the undesirable effect are kept within the tolerable limit. Clear? So all the parameter like functional parameter are come in between the tolerance limit. Okay, then it work properly. Its functional requirement, the undesirable effect if with the tolerance. Because of loosely defined overall design objective, there are number of adequate design available for a single degree problem. Clear? Adequate design is available for the various adequate design available for the single degree problem. Okay. For example, now we have to discuss one example of adequate design. For example, consider the design of shaft in a gearbox. Clear? Now we all know what is gearbox. Okay, gearbox, and we have to design shaft. Clear? So gearbox get the power from the engine through the shaft. The material is selected from the list of feasible material for the shaft and the diameter is determined based on the strength and rigidity consideration. Clear? So first of all, you know all these things, how to define material of any of the product. Clear? Based on its application and its function. So once we discuss the material of shaft, then in your mind the two parameters come in picture. First one, that is what is the strength of the material, and second one, that is what is the rigidity of the material. By changing the material, a number of feasible design can be obtained. Means if you change the material, means instead of steel you are using cast iron. Clear? Or if you are using other material, then all the design may be changed. Clear? All such design are known as a adequate design. Clear? So this is the adequate design. Now we have to discuss second one, that is optimum design. So what is optimum design and how it is differ from the adequate design? So optimum design of mechanical element is the selection of the material and value for the independent geometrical parameter with the explicit objective of either minimizing a most significant undesirable effect or maximizing a most significant functional requirement. Okay. So in optimum design, we have to select the material and also we have to define the value of that material. Clear? from the geometrical parameter. In geometrical parameter, what we consider, once we discuss the spur gear, then we have to consider as a geometrical parameter what we consider, like what is the value of module, what is the value of face width, what is the value of addendum and dedendum. Clear? Based on that, we have to identify which parameter is utilized maximum and which parameter utilized as a minimum value. Okay, so most significant parameter as a minimum, making certain in the design procedure that the mechanical elements satisfy other functional requirement and the other undesirable effect are kept with the tolerance limit. Okay, now next thing, optimum design is carried out on the basis of the most significant quantity to be optimized. Clear? Optimization parameter is the carried out on the basis of the most significant quantity to be optimized, and the consider one example of design of shaft in a gearbox with objective of minimizing the weight. Means in gearbox, how we can change in the design by using, if we use different material, then weight of the gearbox may be reduced. Okay, so objective of minimizing the weight, keeping the material cost with the specified limit. There is a one boundary of the limit of the weight. Here, out of number of adequate design available, there is a single design for which the weight is minimum with the material cost within the specified limit. Such design is known as a optimum design. Clear? So based on that, we can make a one optimum design by reducing the weight of the gearbox. How we can reduce the weight of the gearbox? With the change of the material. Clear? So the basically mechanical design divide in two parts: adequate design and optimum design. Okay, so this is the introduction lecture of the optimization chapter. In this lecture, we discuss why optimization is necessary, why number of parameter is required, and also we discuss the how to design any of the mechanical component based on these two method, adequate design and optimization. In next lecture, we discuss next topic. Thank you.